Okay, so welcome back. Just before we get going, last term, obviously I was off ill. I actually had pneumonia last year, which is why I wasn't in. So, a bit tricky to come to your lectures. Having said that, for weight loss, it's fantastic. Lost about a stone. I did prepare a presentation on core data. So I think Eugene did that one again. Did it make any sense at all? Because the previous week you watched Paul Hegarty on core data. Did that make any sense at all?
No, the video didn't.
Yeah, that's why I did I gave him the presentation to give you. So the core data, really important skill if you're going to work in iPhone development. It's the main way of storing data in the application. So if you want to use it in your app, in your assignment, what you're going to have to do is pull the data from the web service, store it in core data, and then load it out of core data into your table views. If you do that, you have to think about what happens when there's new data. Are you going to delete stuff from core data and download it again? You're going to have some way of getting the updated data, just the changes that have been made. So that's another set of issues you need to discuss. Think about. But core data are really important. Commotion. Commotion is how we access the hardware inside the phone. The two bits of hardware are the accelerometer and the gyroscope. So how do we access the accelerometer and gyroscope inside the application? So I'm going to start off by talking about the accelerometer and gyroscope, but then I'm going to talk about something called device motion, which I think you'll find quite useful. But I'll save it till later. Right, Commotion is the API. So basically, if you're going to use Commotion, you're going to use the gyroscope or the accelerometer in your application, you have to import the correct framework into your application. Just like you did with core data, just like you did with core location, you import the correct library, and obviously you have to add it to your header file. The good news is there's been a gyroscope since the iPhone 4. Anything earlier than that, there's no gyroscope, but if you're targeting iOS 7, which you are, then you haven't got to think about it, have you? Because iPhone 4 onwards, which supports iOS 7, also has the gyroscope. So you have to make sure you import the framework into your project, and then import core-motion.h into your header file, and that'll give you access. There's actually only one key class you need to think about for this. One class gives you access to all the information. A CM Motion Manager object. That's all you need. Everything you need to access is in that one class. But you only need one of them. So in other words, you can have to set it as a property maybe in your application, or if you need to use it on multiple screens, maybe have it in your app delegate and access it through the app delegate. You do not want to have more than one of these. All that will happen if you have more than one is the battery will drain faster and the phone will slow down. So you need one of these objects only. And it's just alloc init job. There's no class methods for it, just alloc init. Now, once you've got your CM Motion Manager, there's two ways you can capture motion data. The obvious one, the easiest one, is you start a sampling process, so you tell the sensors to keep sending data through to generate the data, and you simply poll whenever you want to grab the current status. That makes sense? Just like we did with core location. Remember? We switched the GPS chip on, we started the process, and then we said, right, what's your current location? And it gave them the current location. You can do exactly the same thing with the Commotion. The alternative way of doing it, you know, I ever teach you about blocks? Blocks, block programming. Okay, it'd be a nice little surprise at the end, and I've got a little example to show you. Blocks is an advanced programming construct in Objective-C, which allows you to pass a whole function as a parameter. You know in JavaScript how you can have anonymous functions? Well, blocks is the Objective-C way of using anonymous functions. I'll show you an example. If it doesn't scare you, you can explore it a bit more. And the idea is you tell the CMotion manager how often you want the data, 5 times a second, 10 times a second, every 2 seconds. And then what you do, you create a block which executes every time it gets the data. So it's like it creates a separate thread and runs this block of code every time the data gets sent through. So one's a pull approach, where you pull the data off the sensor when you want it, and the second approach is a push, where the sensor pushes the data to your application. However, let's get onto some code. First thing we need to think about is, does the sensor exist? Now in theory, you shouldn't have to do this, because iPhone 4 and above has the gyroscope, has the accelerometer, they're both present. But obviously it's defensive programming, it's worth checking to make sure the sensors are there and functional. And as you can see, once you've got your CMotion manager object, there's a property called accelerometer available, there's another one called gyro available, there's another one called, well, just those two for the time being, I'll show you the third one a bit later. And if it returns true, the sensor's there. If it returns false, you can't use the sensor. It's always worth wrapping your code in that if statement. And just like the call location, you can start and stop the service. Now this one I'm starting device motion updates, which we haven't talked about yet. There's another method called start accelerometer updates. There's another method called start gyro updates. And you simply call that method, and that will switch on the sensor, and we'll start capturing the data. When you finish with it, you need to stop the motion updates, stop the gyro updates, stop the accelerometer updates, because otherwise it's just wasting processing battery, isn't it? Trying to generate the data you're not using. So we can check to see the sensor exists, and we can start and stop the service. However, just because you've started a service, it doesn't mean the service is running. It might be there's a fault with the sensor. It might be it doesn't start for some reason, I don't know. But it's always worth checking again to make sure the sensor's switched on. And here we are, look, if motion manager accelerometer active, yeah, returns true or false, is it generating some data? So before you try and grab the data off the sensor, make sure it's generating data, otherwise you're going to get lots of nulls. So, does it exist? Switch it on. Is it generating some data? And then we can poll the data. There's two properties: accelerometer data and gyro data. That's it. One returns a CM accelerometer data object, and one returns a CM gyro data object. And this contains all the data about what's going on with the sensor, what the sensor's picking up. So once you've got this data, you need to understand how the data works and what data is contained inside it. Right. The accelerometer data has a struct called acceleration. And that struct contains 3 values: the x, the y, and the z acceleration, the 3 axes of the phone. So if you think about your phone, we can accelerate that way, and that way, can't we? And we can measure the acceleration in all 3 axes. So we need to know which is which. So, that's x, left and right, makes sense, doesn't it? Y, up and down, and z is in and out. So you're measuring data in those 3 axes. Now, all acceleration is measured in g's. Yeah? The trouble is, if I place my phone stationary, it's still got acceleration, hasn't it? What's it picking up? Gravity. Picking up gravity. In theory, if that surface is perfectly level and perpendicular to the gravitational pull, it will register minus 1g, won't it? Okay, that's the, so 1g, I think, probably is pushing back. It'll measure 1g. Obviously, if it's a slight angle, it will change. And if it's dead flat, the x and the y will measure 0. But in reality, you never get it perfectly flat. So you end up with 0.001, 0.02. Okay, it's never perfectly level. The other problem is it measures instantaneous acceleration. So you're going to get huge spikes. If I move the phone like that, I'll get a huge spike, then it'll go down to 0. If I do that way, you get these big spikes. So what you need to do, if you're going to use accelerometer data, you need to put some algorithm in place, filter the data, look at averages, try and take some samples and average the samples out. The raw data is pretty useless because it spikes so much. So, and also, if you hold the phone at that angle, you're going to get some Z acceleration, and you're going to get some Y acceleration, aren't you? Well, that way I get X and Z, they're from gravity, you get the gravitational pull. It's going to affect all of the axes. So it's quite tricky to use accelerometer data in your application. And that's why, before the gyro came along, a lot of the games which involved tilting were very inaccurate. Think about the Wii, you know, remember the Nintendo Wii, the remote. The first version only had accelerometers in it. The Motion Plus had a gyro. So you see the difference between just working with accelerometer data and accelerometer and gyro data. You really need both. Gyro data, very similar. Except this time we're measuring X, Y, and Z. Okay? You've got. Show the diagram easier. Right, there you are. Right hand thumb rule. So basically, if I hold the phone from the front with my right hand, I've got X, Y, and Z. You see how it works? And this time, the gyro data is how fast that phone is rotating. It's not measuring the angle, it's measuring the speed of rotation. In theory, if you know how long it's been rotating and how fast it's rotating, you can work out angles. But again, that's why we get this horrible inaccuracy. So, radians per second is the unit, and it's measuring rotation in 3 different axes. So, X is that way, Y is that way, and Z is that way. Okay, so let's go back to that slide. So what we're measuring, we're measuring that rotation, and it returns doubles, high precision double floating point numbers. So what I've shown you so far is fine, but it's very difficult to work with. So what I'm going to do now is show you something called device motion. Now device motion is a smart combination of the accelerometer and the gyro. Okay, and the idea is by combining data from both internally and applying internal algorithms to the data, you can generate more useful information for you to use in your applications. Okay, so what we do this when we have a CM device motion object, okay, rather than a gyro object or an accelerometer object, and let's start with acceleration. Remember the problem with acceleration? Gravity. We had a problem there. Whichever angle we use, gravity impacted on it. Well, what it does now, you've got 2 different acceleration properties now. You've got acceleration due to gravity as one property, and acceleration due to user as a separate property. So what it does is remove the gravitational effect on the accelerometer data for you. So you can now measure how fast things are rotating in all the axes without worrying at all, moving in all the axes I should say, without worrying at all about the gravitational effect. So suddenly those movements, you can now use those movements more usefully. So you can see, look, I've got a CM device motion, I've then got a CM acceleration object, and a CM called gravity, and one called user acceleration. 2 properties now. Much more useful. But more useful, see up to the minute, rotation data. With the basic rotation, you've got a problem, because the Earth's rotating as well, isn't it? The device is rotating, the Earth's rotating. So you get a bias creeping in, depending on which angle you're holding it at. And also the sensor itself has a 0 bias in terms of what it recognises as 0, 0. So the gyro rotation rate, which is part of the CM rotation object, is now bias removed. So all the rotations are now accurate. There's no bias in that at all. So these rotations, you can now use those as part of your application. The best thing though, the thing which you will use more than anything else, is you can measure attitude, angles. Something called a CM attitude object. So now, there's my phone. I can measure the roll of my phone, the exact angle in radians of my phone, the pitch of my phone, just like an aircraft, and the yaw of my phone. And it's insanely accurate, these angles. So we're not measuring the change in angle, we're actually measuring the angle itself. So in a pinball game, you want to measure the angle of the phone, don't you, in different axes. Well, now you can do it. Right, now, the last thing we'll talk to you about, so it was a short session today, didn't I? Because I know you want to get on with your assignments, finish them off. Blocks. Registering blocks to receive data. Okay? You don't need this information, but blocks are a part of the very advanced stuff in iPhone development. So I'm going to mention them and show you an example. So, instead of asking the sensor for data, in other words, pulling the data from the sensor, what we can do, we can use a block and we can create a queue. So what we can say to the sensor is, I want you to send your value back 5 times a second. And every time it sends the data back, we're going to shove it on a thread and execute some code. So can you see what benefits that might have in your application? What would be the benefits of having this block approach, block and queue? If we're pulling the data, okay, we're asking the data when we want it, we've got to build that mechanism into our program, haven't we? We've got to have something which asks for the data. If you have this sort of queuing approach, you let the sensor, the API of the sensor, do all the hard work for you. You simply say, 5 times a second, run this block of code with the latest data. You've got a separate thread, so your user interface is not tied up, and it's a cleaner way of doing it. But to understand this, you have to understand blocks. And blocks are going to mess with your brain. Okay? I'll leave the block slide till near the end because I want you to not kill yourself at this point. Okay, you can do that towards the end of the session. It's a very weird syntax. Now remember I said Objective-C was weird syntax. Now this is weird syntax in a language which has weird syntax. Okay? And there is a block. So let's have a look at this code and try and break it down so it makes some sense. The first thing we do is we create an NS operation queue. That's simply a queue, a thread, which we can use for these samples. We do not want to use the UI thread for this, do we? Otherwise it's going to get very jerky, isn't it, when you try and interact with the application. We want to push all this work into a separate thread, and that's what this does. You've done threading already, haven't you, for the images? Showed you how to pull threads, use the correct threads. So, it's a method of the motion manager. So let's take this one bit at a time so we understand what's going on. Right, is it a property or a method? Starts with a square bracket. Property or method? Guys, what is it, a method or a property? It was 50-50, wasn't it? Square bracket, remember space, not a dot. It's a method. It's a method of the CM Motion Manager. Now, this one it's a method with 2 properties. The first property, look, start accelerometer update to queue. The first property is that queue, that NS operation queue that I've just created. Look at the second property. With handler, whoa, we've got strange characters going on. That's called a caret sign. That caret sign says this is a block. The second parameter is a block. That parameter goes all the way from there, all the way down to there. That square bracket there, that square bracket there matches that one there. Can you see, if you've done JavaScript before, which you have, you've used anonymous functions, haven't you, before? It's a very similar structure to an anonymous function. But this one has parameters. So it's an anonymous function, so it hasn't got a name. A caret means block. This block takes two properties, two parameters. The CMXL data, makes sense, doesn't it? And an error object. And then look, it's just code in there. But, get ready for this one. There's a procedural type function there, which takes another block. There's a block inside a block. And that block is the method block, and this one is dispatching the queue. This is emptying the queue. What this says is take the first item off the queue, and then we do something with it. So what we have there is two blocks. The first block takes two parameters, and the second block takes no parameters. You see, there's no brackets after the caret sign. So all the block is an anonymous function. If you've ever used JavaScript to do anonymous functions, you'll know exactly what I'm talking about, which you have because obviously you're doing 305. And that is how you handle the sensor data. So you literally just put that code in, and that code will execute every time the sensor sends some data through. The only problem we've got at the moment is we haven't told the sensor to how often to send the data through, have we? We've created a block which said start accelerometer updates to queue, not to start accelerometer updates. And so we've now pushed all that sensor handling data code into its own thread, which means the user interface is completely freed up by user interface, and it creates a queue. So it keeps pumping this data onto the end of the queue, and this code will keep executing through the queue until it gets to the end. And there's the magic missing ingredient. We have to tell the CM Motion Manager object how often we want to send the data through. And it's a floating point number, and that says every 3 seconds send the value through, which is rubbish, isn't it? What's the more reasonable value for this if you were using accelerometer data? 3 seconds interval seems a bit huge, isn't it? 0.1, 0.2, you want 0.05, you want at least 10 times a second, don't you? Depending on the application. If you put that in, it will automatically now trigger that block every 3 seconds with the latest accelerometer data. Does that make sense? So you've now got a way of separating all the logic for the accelerometer data into its own block, creating up the user interface thread, and it will just then go away and do it in the background without having to worry about you doing anything at all. So I said it was a short session today, and I was right, about half an hour rather than the 50 minutes. So, core motion. It's all about handling the motion sensors, the gyroscope and the accelerometer. Remember, you've got 3 objects. You've got the accelerometer, the gyro, and device motion. You'll probably never ever use the first 2. It doesn't make any sense to use the first 2 because the third one does everything you want anyway, without all the errors and the bias and so on. The other 2 are still in there, but I'm beginning to wonder whether with iOS 8 they might start deprecating. Because now every device that supports iOS 7 has both sensors in. It makes sense to work with the device motion object, CM device motion. So I left this topic to last because I want to cover it with you because it's important, but it probably won't be used in your application, your assignment. So it means you can focus on getting your assignment finished off without worrying too much about the about extra information. Right, before we finish, the assignment. Who's finished it? Okay, right, who started it? Okay, that's hopeful. Today? No, you've been going some time, haven't you? Are there any issues that you're having with your assignment? Because all I want to do is identify them, and then I can brief the guys on Thursday to give you extra help with those topics. Let's go through the topics we've covered so far. I'll go through the list. Right, web service API integration. Getting your data from your web service into your app. Has everyone got that working? Anyone having problems?
I told you earlier.
You took my problem with that problem earlier. So we'll get that sorted out on the app on Thursday. I don't know what's causing that problem. Quite a quick show of hands. Who's had to modify their API? I always modify my APIs. Yeah. Because as you go along, you're finding issues, aren't you? The way it works. Ideally, your client should be a dumb client. Should be very lightweight. So remember the example I gave you from the bookshop. When something went wrong, the client, all it said is something's gone wrong, just display whatever message comes back from the API. There was no business logic in my app at all, was there? If it comes back success, display it. If it comes back failure, just pop the failure message on the screen. Yeah? So really simple. So if you find yourself doing complicated things with your data, you might want to make changes on the API to simplify things. Because in about 7 weeks' time, I'll be showing you how to do API work with Android. What you don't want to do is have to take all your complicated logic from your iPhone application and re-encode it in Java for your Android application. And then re-encode it in JavaScript for your jQuery mobile app. You want to keep it on the server, keep it out of the way. Okay, a multi-threaded. Anyone using multi-threading in the application? Anyone using any images or graphics or anything? If you're using graphics, I would strongly recommend multi-threading. If you think about downloading images from the web, you want to stick that in a separate thread, for sure. Then we covered core location of AppKit, and I've kind of...
Do you want it off?
Well, stop installing it. I think I've moved.
Is that?
Okay, then we talked about core location. I dropped some subtle hints as saying that you really want to put some graphics in your app, if you can, so you can practice using the multi-threading. And were you to happen to have a bit of geodata in your web service, that wouldn't go amiss either. Anyone using geodata?
No.
Anyone got location data in the app? Not yet.
Not yet, yeah.
Okay. That's all I'm saying. Now, if you get a chance, have a go, because it's, you start putting maps in the app and it gets a bit more exciting, doesn't it? A bit more, if you don't get a chance to do it, don't worry too much. It's just. Obviously, remember, it's not just for this assignment you're doing it. It goes in your portfolio. When you start applying for jobs and getting out there to interviews, the cooler the thing looks, the better. Then we didn't do advanced navigation because I was off sick. We did core data Stanford style, which didn't go down too well. Then we did core data my style, or Beauty style. Did you understand core data, first of all? That's question one.
He explained it better than the Stanford dude.
That's comforting to know. He's supposed to be the expert on the subject. Although he does get a bit waylaid, doesn't he? A lot of depth and detail, which I'll possibly ignore. Anyone decided to use core data with their application yet? Not done it, but thinking about using it?
Yeah.
Yeah? You can give it a stab. I'd get everything working first, and then put core data in afterwards. Okay? Because big but, even if you're not sure, create your project and tick the core data option. Because remember, you have to define whether you're using core data when you create your application in the first place. It's very difficult to go back and retrospectively add core data to the application. It's possible. You can copy and paste some code from the app delegate. But even if you're not sure, I'd still tick the core data box, because it just creates your asset, doesn't it? XC data asset. And then if you don't use it, it's no loss, is it? Otherwise, you have to create a new project and copy and paste all your files into it and try and get it working. So core data and Commotion probably not, because it's not really relevant to the project at all. It's just something that's cool. So that's it on iPhone development. There is no more. All I've done is point you in the right direction and given you a gentle shove. in the last 12 weeks. I could do no more in 12 weeks. There's not enough time to cover everything. I could spend the 24 weeks on iPhone development and still have stuff I want to teach you. I mean, what we missed out with some of the advanced interfaces, navigation, we didn't cover collection views. We didn't cover tab bar controller, but that's pretty easy, you'll figure that out yourself. I mean, things like Sprite Kit would have been cool to have done, wouldn't it? A bit of stuff on Sprite Kit. But again, what I hope I've given you over the last 12 sessions is enough knowledge and experience to go away and learn the extra stuff yourself. And kind of, I'll point you in the right direction. Next week, we start with Android. Now, the good news is the videos for the first 4 to 6 weeks are already on Moodle. So as soon as I finish today, I can release that, and you can watch the videos before you come. Not this Friday, but next Friday. But while I'm on the subject, the studio, you've seen the nice graphics, haven't you, on the glass downstairs?
Yeah.
That's just before Christmas that was done. That's because we're setting up a commercial development studio down there. So the idea is we're setting up a commercial arm of the computing department. So at the moment we're trying to register a company's house and get a proper company set up. And the company is for you. I've got clients who contact me on a regular basis asking for apps and development with them. I want to have a proper company to do the work where we can invoice the client and get the money in, we can pay you to do the work. And that's the plan. So we have a setup which allows you to get some experience, you to get paid. Yes?
Are the old projects still available?
What old projects?
The ones that you pitched to us the other time?
Yeah, I'll go for them. Before Christmas, because I was off ill, we kind of fell apart a bit, so we're going to start it up again this term.
A lot of units doing today. A lot of units started around here.
It's very important.
That's how to take money back.
The idea is, the reason we're doing it under the studio banner is because when you go for when you do your CV or put down your experiences, you can then put down the studio rather than Commotion University. So it looks a lot better. You work for a commercial organisation, and the university has a lot of experience of doing these, doing spin-offs. The Technopark over there has dozens of companies which started off as internal to the university and got spun off to external organisations. And that's what we're trying to do now. So if you're interested in doing work, I'll keep you posted. We're setting up a group, a website with the jobs and the information on in the next 2 weeks or so. And I've already got a handful of projects coming in. I had another meeting with the guy from Germany today. He's got a project, it's an Android project, which he wants to start in about a month's time. By that stage, guys, you'll have enough experience to do this. So if you want to get involved in that one. So I'm going to try and get the communication going and try and get things moving a bit on that one. But the idea is you will work for the studio, working together in teams on these projects. And hopefully you enjoy the experience. So, was the iPhone module okay? Did you manage to get much out of it?
Yeah.
Is there anyone who thinks iPhone development's for them, who actually wants to get a job in iPhone development? Okay, I'll be first to argue, but anyone who never ever wants to see iPhones ever again? That bad, then? Windows Phone, right, okay. So for your next project, we can develop a Windows client.
No.
Well, where's the challenge? You can do a Windows Phone, C#.
Windows in laptops, but Android in phones. Yeah.
Right, so you'll see how you get on with the Android development. The issue you will have with Android development is Xcode, or rather lack of Xcode. Android Studio is, how can I put this?
Archaic.
Not archaic, it's brand new. Not very user-friendly. Not very user-friendly at all. If you're going to install Android Studio on your laptop or your computer at home, I have one warning for you. When you install it, you get all this what's called canary updates, which means you get updates every time they change a variable name. Which basically means, if it breaks, you'll get the broken update. What you need to do is go to the settings and change it to developer updates. And that way you only get the updates when they're stable. But the default is you get every update. You know, developer picks in those, you get an update to Android Studio, which means every week or so you get a new update, and most of them are broken and stop it from working. I mean, the last one I did before I realised you couldn't create any new classes. That functionality was broken. It's, you know, pretty fundamental. They fixed the crashing issue, but then you couldn't create classes. So stick to download the version straight away, go to the settings and make sure you get developer updates, not canary updates. Okay, otherwise you'll spend your whole life reinstalling Android Studio. And you need Java, the Java runtime installed as well for it to work. Okay, and that's it for this half. You are halfway through the course. Realistically, you're halfway through this time next week, aren't you? Rather midnight, 11:55 PM. I think that's the watermark, isn't it? That's when you really are halfway through the course. Okay, thank you very much for putting up with this for 12 weeks.